Mr. Riley, and I'd like to give you guys a demonstration of Lab 3, Section 1. So, we're going to configure Wireshark and generate network traffic. So, we're already logged into the V workstation, and we're going to double click on Wireshark. It's going to take a moment to start up. In the capture section of the Wireshark, click on the VMX Net 3 Ethernet adapter number 3. So, this one right here. And actually, if you have multiple network cards, you have to choose the one you want to listen to because they could be on different subnets. And, you want to capture the traffic that you want to from the correct subnet. And that's what this note kind of leads into about. So, now we're going to click the little fin here. Under capture, rather. And start. Stop. Okay, so capture, start. So we're going to go ahead and minimize a Wireshark window and generate some traffic now. Okay, we're going to go ahead and open up the command prompt down here in the taskbar. And we're going to do a ping command, which is an ICMP protocol. And that should give 4 ping messages. And you have your time to live, the IP address you were pinging, and how long the round trip time was, like 1 millisecond. Okay. Now we pinged. If you do the arrow up, you get the previous command. So we did 172, pinged 172.30.0.1. Let's do the same thing, but to 172.300.3. And it replies. If you look at the topology, there is things at each one of these. And we're going to do it again to 5. 172.30.0.5. And these are different different pieces of equipment on your topology. If you look back here, scroll down, you will actually see your topology here. So, dot 3 was the switch, dot 2 was the workstation, dot 5 was the file server, and dot 1 was the router. Okay. So each one got 4 packets, like it says here in the note. And make sure you read the notes. I'm kind of going through this quick for brevity, but, read through it, get to understand this, because this is going to be probably part of your job one day. Now we're going to go ahead and open up PuTTY. And we're going to remote into a piece of equipment. Now you can do this different ways. So what you do is you put the IP address or host name right here and click the other, and we're going with, this is going to be telnet, so which is unsecure. So anything we send back and forth this way will be visible. And we're going to go ahead and open, and then we're going to log on with user and password. Now you will not get any feedback as you're typing in password. That's just a Linux thing, so don't freak out about that. Just type in password and hit enter. So please note the PuTTY will not display your password inputs on the screen for security reasons, just like I just said. But rest assured your inputs are being logged. If you do not enter credentials within 30 seconds of opening the session, PuTTY will automatically close it. Now that you have established a telnet terminal session with switch 01, in part 2 of this lab, you will review the Wireshark capture file and look for unencrypted passwords in the data payload. So go ahead and close the user switch PuTTY window. So you can do that just by typing exit, and away you go. Okay, If you click the X, it'll say, are you sure you want to terminate? And that's when you click OK. On the workstation desktop, double click the putty icon to open up a new putty window. And now instead of going in, we're going to go into 172.30.0, oops, 0.1. And we're going to use SSH, which is port 22, and it's right here, SSH. So, in the next steps, you will generate FTP traffic by performing an FTP file transfer between the V workstation and the file server host. In this transfer, the V workstation will be used as the client and the file server as the server, obviously. So, FTP and trivial FTP are non-secure file transfer protocols. So anything you send can be captured in Wireshark and viewed by whoever captured it. Oh, actually, I skipped a step. I'm sorry. We're going to go ahead and click OK. And we're going to type in admin and PFSENSE. Now we're logged into the pFence firewall. And then we can log out, assign interface, set that, but that's for a different class. So we can go ahead and close this by 0, enter, and it closes. Okay. Now, this is where we're going to do the file transfer. I kind of got ahead of myself, apologize. So, FileZilla. In the FileZilla client window, type the following information and then click Quick Connect. So, host 172.30.0.5, username FTP user 01, password. I'm sorry, I think that's capital P. Yeah, capital P at SS at SSW0RD exclamation point and port 21. Then click on Quick Connect. And then you'll get, when prompted, click OK to acknowledge FTP session will be unencrypted. It says this server does not support FTP over transport layer security. If you continue, your password and files will be set in clear text. So go ahead and click OK. Okay. In the remote server site, double click the data directory to specify your target directory. The local and remote site sections are each composed of two panes. The upper pane shows the directories on the file system. The lower pane shows the files in the currently selected directory. In the local file section, navigate to C, Users, Administrator, Documents. So, C, Users, Administrator, Documents. And then in the lower pane, right-click the admin report file. So, oh, I'm sorry, admin report PDF file, and select Upload. Ah, okay. I think I already uploaded this because I did it earlier. It would be under my documents here, and you would, but I already uploaded it in the data directory, so it would show up there. Okay, well, let's do this. We'll do a download. Okay, hang on a second. Let's start out from the beginning. C. Users. Administrator. Documents. There, it was hidden. Okay. Right mouse click, upload. And it's already there, so it's okay to overwrite it. I just want to generate traffic, so I'm overwriting it. Okay. The next steps, you will generate secure FTP traffic by performing a secure file transfer between the V workstation and the file server 01. Unlike FTP, secure FTP is a secure file transfer protocol that encrypts the payload. Okay, in the FileZilla window, type the following and click Quick Connect. So that's already there. FPT user 1, the password, but we're going to change the port to 22. Okay. When prompted, click OK to end the current. Oh, okay. I'm going to close this and just start over again. Okay. Host 172.30.0.5. Host name FTP user 01. The password and port 22. Quick connect. Okay, as you notice, we did not get that warning message. In the remote site, double click the data directory. Just specify the target directory. In the local site, click admin report MD5. So, right here. And select upload. And I did this earlier, so I'm going to go ahead and overwrite it. So, and it's showing the status of how it's going up here. In the bottom pane, select successful data transfer to view the log files. And there you go. It would say 2, but I closed it and reopened it. So, and this is where you take a screenshot. So we're going to go ahead and close the FileZilla window. And then we're going to go back to Wireshark and stop the capture. So if you can do it a couple different ways, capture and just click stop or hit the red button when it was there. So as the Wireshark menu bar, click the file menu and select save as. So, file, save as. And we're going to put Riley underscore capture file. And I'm going to put a 1 after it because I already have one of the. Well, actually, I'm going to leave it as is. And let's move on to part 2, where we analyze this traffic. Oh, hang on a second. Did they want us to close Wireshark? They didn't say, so let's go ahead and move on. Okay, in this part of the lab, you use Wireshark to analyze and generate traffic captured in part 1. As you have noticed, you have started the capture section. Wireshark analyzes Analysis, view contents in 3 pages. At the top of the page, Wireshark window contains all the... Okay, I'm going to close this and open up my file here. This is one I did today, and you can tell by the... Here's the third pane down here. And you can grab them and adjust the panes as needed. So on the Wireshark toolbar, type ICMP up here. ICMP, hit enter. Now this is ICPM for IP version 4. You could do an IP version 6 if we were using that before. So this brings up all the ICMP messages that went through. And this is a filter because there's lots of packets that go back and forth, but we just want to look at the ICMP. Display filters allows you to limit the packets in the packet list to just the ones that interest you. So, okay, each column in the packet list pane displays descriptive information about the specific packet. Here are the columns and what each mean. Number, NO. This is the packet number according to the sequence and how they were captured. Time, this is the timestamp of it. Source, the source IP address from which it originated. The destination, where it's going. And the protocol column, ICMP, and that's how we filtered it. The length of the packet, 74 bytes. And information, this contains other details about the packet from the header that wasn't already been shown in the other columns. You can see how each ping request is followed by a ping reply, which responds to a successful ping command with no packets lost. Additional info includes connection ID, all the same values for which indicate there is only one connection, and the sequence, relative sequence numbers. In the packet's detail pane, double-click the first frame row. Expand this a little bit so we can see it. And that's the middle pane. Expand the frame row. And it gets you information about the packet. So, interface. So, if you expand this, it will actually tell you information about the interface. Who sent it? A student. Arrival time, time shift. Epoch time has to do with Linux. It's a number of seconds since 1970. And don't worry about that until you get to Linux class. Okay. In the packet details pane, double-click the second row, Ethernet 1, or I'm sorry, Ethernet 2. I'm going to close frame, Ethernet 2. Destination, and it has the MAC address of the destination of that network card. Source VMware address, and the MAC address for that, or the physical address. And this would be at the data link layer. Because the data link layer focuses on LAN communication, the address is the most important. The address that is the most important is the MAC address, and I showed you this right there. A MAC address is made up of 6 hexadecimal pairs. The first 3 pairs are unique to the manufacturer, like Apple, Lenovo, Gateway, HP, whoever, right? And the last 3 pairs are unique to that, just a random. And the last 3 pairs are unique to the hardware device in this case. The MAC address represents the VMware as the NIC manufacturer because this is a virtual machine. In the details, double-click the third row, Internet Protocol version 4. I'm going to close this. And this header length, 20 bytes, different services, flags. And these are the flags that were set in the packet. This line details the network layer info, layer 3. Which means the source and destination IP address are looking for an ICMP message. Source, destination IP address right there. In the details pane, double click the fourth row. Internet control message. To display additional information about ICMP. So checksum, that means it checked the packet to make sure it wasn't corrupt. It was a ping request. Identifiers, sequence numbers. So you should notice much of the information listed here is what you see in the info in the packet list line right here. In the next step, you'll examine the payload directly to verify this. So in the packet detail, double click the data subheader. So we're going to slide this up a little bit. Data. And this is, we highlight data here, and then it shows what was actually in the data. And what this is basically it's just padding, or it's an ICMP message, so it just sends A, B, C, D, E, F, G, like just letters. And you're going to take a screen capture of that, like if I showed you mine. Okay. Okay, in the next step, you will apply a filter to isolate traffic for the telnet session. So we're going to go ahead and clear this filter. And we're going to apply a new one. And we're just going to type in telnet. And when it goes green, it's a good command. So now we're just showing the telnet protocols. So in the packet detail, double click the fourth row, transmission control protocol. And I'm just looking at the first one here. Unlike the ICMP, which operates at the network layer, Telnet is an application layer protocol that uses TCP, Transmission Control Protocol, as a connection-oriented transport layer protocol. Connection-oriented guarantees delivery. So you see the three-way handshake. TCP handshake sync is performed between the sender and receiver. So actually, if you look in the flags, you can see the different ones. So acknowledgement, push, acknowledgement, push, like so. Acknowledgement packets sent for each packet to receive from receipt. So it checks everything that it sends, and that way, you get complete communication. Sequence numbers are assigned to each packet for the purpose of tracking each packet and properly reassembling them at the destination. So I'll close that. Sequence number. That's a sequence number. And they'll get like 1,500 packets, and they'll each have their own sequence number, reassembling them properly. Okay. Let me close up some of this. We're going to go ahead and expand Telnet. In the packets detail, double click the fifth row, Telnet, to expand it. In the details row, shows how Telnet is configured to operate. In this case, Telnet will negotiate between the source and destination computers to determine the best window size, terminal speed, and that way, like have you ever seen how you're doing a download and how the speed will change? That's actually them communicating, saying, I can handle faster speeds or slower speeds. It is recommended never to use Telnet due to the lack of confidentiality support. Telnet is considered an insecure protocol because it is not encrypted. The packet payload, data being transmitted, the user ID or passwords are transmitted in clear text. So, okay, in the packet list pane, click the first packet to select. And I'm gonna collapse this a little bit. This is them negotiating right here. And then press down the arrow key to step through the packets over time. So I'm going to click on this one up here. Sorry. Click up there. Won't display location. Commands. Okay, if you look at this right here, PASSW0RD, the password in clear text. So it was right here. You could see that. Okay. Select the last telnet packet and should contain. I think it's okay. Under telnet. Okay. Oh, I typed an exit. That's why. It actually picked that up. So that's what you're looking for right there. Last login packet. This information is echoed to the remote shell after successful logging in and shortly before receiving the username. So, okay. So on the Wireshark toolbar, in the filter bar, we're going to go ahead and erase what we have and create SSH. Enter. And now we see the SSH version 2 if you look at the protocol. These packets are associated with the SSH version 2 session to the pfence gateway router, that IP address, from part 1 of this lab, as well as a secure FTP session from the file server 01 at 172.30.05. SSH version 2 also uses TCP as a connection-oriented transport layer protocol, which means that it incorporates a TCP three-way handshake, acknowledges packets and packet sequence during the track, and reassemble packets at the destination. Unlike Telnet, it encrypts the payload, and this means the user ID passwords are not set in clear text. Okay, so let us go up here. On the Wireshark toolbar, place the cursor at the end of the SSH string, and we're going to filter it a little more. And at IP add equal, oop, no, not plus plus, equal 172.30.0.1. And so it just narrows down communication with that one location. Okay, in the packet list pane, click the first packet. So well, I don't mean to open up that all the way up, but yeah. And then to select it, then press down the arrow key and examine. Okay, SSH protocol. And you can see there's no compression, but they're using AES 256-bit encryption with HMAC SHA to version 2 256-bit encryption. And you don't really see, and the data down here is all encrypted. You can't read that. Packet list server, in the packet list pane, select the server key exchange INT packet. So click it in the packet details, double click the SSH protocol row to display the SSH details and examine the encryption hashing algorithm. And that's what I was talking about, the AES 256 and the HMAC SHA-2 256. And that's the actual encryption right there. The note MAC refers to not to the physical address or MAC address of the host, but rather the message authentication code, which hashing one-way encryption function to confirm the authenticity of the sender. They are who said, so they know who they are, and confirm the data was not corrupted. So we're going to do a screenshot of that. Okay, so we can't read this like we could the last one when we do an FTP. So in the filter bar, highlight 172 and type 5 instead. So we're going to change locations. So what this does, press enter to view the SSH packets associated with the secure file transfer with file server 1. So, and you'll notice the source, the destination has changed here. There should not be much surprise, but the packet sequence looks much the same with the default gateway. The difference would only be viewable in the commands issued, given this session issued some file transfer commands, rather than login commands. So it's like the first server encrypted packet. So initially they have the key exchange, ecliptic key. Okay. In the packet details pane, double click the SSH version row, which I did, to view the details. So, and it shows it was encrypted with AES 256, and there's the hash from the HMAC, the encrypted packet. So you really can't read the details here. Note, as you learn by reviewing ICMP payload, each time you select a field in the packet details pane, some or all the data in the packet bytes is highlighted. This is Wireshark's way of indicating the hex ASCII data correspondence. So that corresponds with the highlighted area, making it easier to drill down to the information relevant to your investigation. In this case, you're displaying all the encrypted message data. So you're going to take a screenshot of that. Now, we're going to change this to FTP. The FTP uses TCP, Transmission Control Protocol, as a connection-oriented transport layer protocol. The key difference between secure FTP and FTP is that secure FTP encrypts it. It's right there in the name. So locate and select the packet response 227 entering passive mode. Okay. Information, TLS. Username, password. .227 entering passive mode. Okay. Okay. So you may have to look around a little bit for it, but in the packet details pane, expand file transfer protocol, which I have already, to view the details. Working directory, command frame, entering passive mode. Okay, note the FTP connection operates in two modes, active and passive. In active mode, the client first sends a port command to the server, typically using control port 22. And in the message specifies a random port number, which will be listening on the data connection, typically port 820. Upon receipt, the server initiates the data connection back to the client through a specific port. This is a mode of operation used when FTP first came about, though it is much less commonly than passive mode because nowadays most clients are behind firewalls and do not permit incoming connections to their machines. However, external servers, such as public file servers, do accept incoming connections. So passive mode was created to exchange connections operations to act in only one direction, client to server. Okay, we're going to take a screenshot of that. Okay. Now, on the Wireshark toolbar, highlight the text file, and we're going to just look at the data for FTP. Okay. In the packet in the packet list pane, select the first FTP data packet sent from the workstation. Okay, so the source is 2 to the file server 5. Okay. The packet details pane review the TCP details. Right there. And this, if you look source port, destination port, and you see how they're not 20 and 21, but they're randomized. How long the TCP segment was, the sequence number. And actually, it just shows one here, but that's the actual sequence number. They call it the raw number. And the next sequence number will be 1461 since they're sending 1460 packets. The ACK number, so, and this the actual, so, flag ACK. Expand that out. You'll see the acknowledgement set. Okay. So go ahead and do a screen capture of that. Now that finishes up Section 1. I've already got videos for Section 2 and Section 3 that'll be posted to YouTube, and I'll have links in Blackboard. So, have a good day, everybody. Thank you.